Okay, so now that we have covered kinematics, the exercises, right? Let's talk about a small relation with dynamics. So this is our first introduction of dynamics, F equals ma, right? And roughly speaking, I just want to tell you how kinematics and dynamics relate to one another, and the answer is through this equation, F equals ma. So as we know, if we know the position of the particle with respect to time, we kind of know everything we need to know about it, because we can derive other quantities from this expression. So for example, if we do know an expression for x of t, then we can take the derivative with respect to time to get the velocity of respect to time. We take this derivative again to get the acceleration with respect to time, and we can calculate basically every other thing, right? We can plot this function to find the intersections with some other particles, perhaps some other graphs. But the question is, how do we get this x of t? And the answer is that unfortunately, the equations of motion do not give us x of t directly. Instead, nature has it that Newtonian mechanics will give us the acceleration as a function of time. And in order to find the position as a function of time, we need to integrate the acceleration twice, right? So integral, when you do the integral, is the antiderivative. So if you know the acceleration, you can integrate once to get the velocity, you can integrate another time to get a position. So that's why the second integral. So we take two integrals, and this will also leave us two integration constants. So for example, if a is, let's say a of as a function of time was t, okay? Okay, let's keep it simple. Let's say a as a function of time was a constant. Then we have the Suvat rules, right? And we know that s of t is equals to half a naught t squared plus v naught t plus s naught, right? So a naught was a constant that we were given, but v naught and s naught were integration constants, right? When we perform this integral. And that means that the F equals ma is able to tell you how the particle accelerates. It's able to tell you this term over here, right? So F equals ma, dynamics will tell you the quadratic response, right, to the acceleration. But it will not tell you what's the initial velocity and initial position. So these are known as initial conditions. And these are inputs that we need to know from the question or from the setup. And these are inputs that we are unable to get from dynamics. So in other words, dynamics is responsible for how the position of the thing changes with respect to time up to second order, whereas the initial conditions will tell you the first order and the 0th order behavior. So yeah, that's just a small look into dynamics, but we'll cover Newtonian mechanics in the next section, so don't worry too much about it. I just wanted to highlight the connection between dynamics and kinematics.